announcement is it impacts this class big time. There's several announcements that will, here's Sarah. There you go. Okay, I knew you were up there. Okay. Now, several, and this is part of the reason I don't know for sure if the math team's going to meet. This week is turning out to be a bit strange as far as requirements go. Number one, tomorrow morning I have a doctor's appointment. I have my hematologist only sees patients on Tuesday mornings. Mine's tomorrow morning, 8 o'clock. I have to be there for labs at 7. I'm hoping to be out of there and back here on campus before too late. Okay, but I know my 8 o'clock class will not meet, and therefore we're going to make up that class at 12:30 tomorrow. Okay, so my office hours, normally on Tuesday and Thursday, are 12:15 till 3:15. Tomorrow will be 1:45 until 3:15, because I'll be making up that class from 12:30 until 1:45. Okay, so that's that change. All right. Wednesday morning. This is something I saw in the email just over the weekend, and it's a little confusing, but I'm going to, I know you're in here. I've just got to find you. Kara, right? Okay. And you may have seen it posted when you came in. This building will have a fire drill Wednesday morning at 8:30. Smack dab in the middle of this class. Sorry about that, okay? Hopefully it won't last too long. We can come back and wrap up the class. But it is scheduled for then. Now, if that wasn't enough, what they said in the email they sent to us is take all the classes out the back door by the admissions desk, and that is not how you run a fire drill, okay? No, you're in here. There you are. You're hiding on me. Okay, Frank's here. You go out the closest exit. So when I saw the email, I responded to it last night. So far, I don't know if they've responded back again, but you don't try to get everybody out one door. You go out the closest door and get away from the building as soon as possible. It's right back there on the stuff that I posted right at the beginning of the term. Our closest door, as we said before, go down this half flight of stairs, take a left, go down fully, and then go out of the building. Don't go to the back of the building. Now, normally we would meet in the parking lot down there, okay? They're wanting, I think, everybody to meet in the parking lot behind the building. So we'll go back there. It wouldn't be what we would do during a fire drill, during an actual fire. Kayla is here. What we're talking about is there is a fire drill scheduled for Wednesday morning, 8:30, okay? So what we'll do, we'll go out like we're supposed to. Now, if I hear differently by Wednesday, I'll let you know. But normally we go that way. And what they say, they want us all to meet in the parking lot back there. So what we'll do is go as a group in that direction, okay? It would be a dumb thing to do if there really was a fire in the building, because then you could be walking right next to a building that could have windows being blown out and stuff like that. It's not what you normally do, but I think they want us all there so they can talk with us. So that makes sense for a fire drill. Just know it's not what we would do during an actual fire, which will never happen here, okay? All right. Any questions? All right. So if that's not enough, that interferes with class on Wednesday, but doesn't adjust my office hours any. But then on Thursday, we have a faculty meeting at 2:30 in Ethel Hall Auditorium. So normally my office hours are 12:15 till 3:15. On Thursday, they're going to be 12:15 until 2:15, because I have to allow myself a little time to get over there for the faculty meeting. So those office hours have changed. And then there's really sort of one of those bad news, good news situations, okay? The bad news is Friday's a holiday. There's no school. Campus is closed. But the good news is it doesn't affect us any. We won't lose any class time over it. Isn't that great? Okay. Good deal. All right. Any questions about announcements or things coming up? Strange week this week, but Veterans Day is Friday, and we do want to honor that. All right. We are recording. Any questions before we get going today? All right. We're on page 205. This is section 4.4, chapter 4. Chapter 4, by the way, is rational expressions. And 4.4 is more on rational expressions than complex fractions. And today we're starting with complex fractions, which I don't like the name for, because in math, complex means some imaginary component, generally. That's not what we're talking about here. I would say complicated fractions, but I know what they're talking about. All right, what complex fractions are by their definitions are fractional forms that contain fractional forms, that contain other rational numbers or rational expressions in numerators and denominators. So you see a rational expression has a ratio of one expression to another expression, one polynomial to another polynomial. These are not polynomials anymore. These are rational expression, ratio of one rational expression to another rational expression. These are polynomials, but now we have ratios of rational expressions. So that's why they call them complex, because you have fractions within fractions. Okay? Now, these are all samples of this. This is with variables in them. This is with no variables in them. Variables, rational expression in the numerator, but not one in the denominator, unless you, of course, realize that's 2 over 1, and that is a rational expression. And here you have just an integer in the numerator, which can be written as a rational number over a rational expression in the denominator. And we'll talk about how to simplify each of these. And that's what we're dealing with, is simplifying these rational expressions. We'll actually take the first one first. Okay? Well, nope, we won't, will we? All right. It is often necessary to simplify a complex fraction. Okay? We'll take each of these 5 examples we just had and examine some techniques for simplifying. There's more than one way to skin cats if you don't like cats, okay? But we will just, do it. I'll tell you the one I think is most appropriate or easiest on each of these types, but really there's several ways you can go. How would you approach a problem like that? Any ideas? What does that mean to you just looking at it? Ah, very good. That is a division problem, okay? And as such, we could rewrite this as, I'll do it down here. Let me get my pen activated. And Nick is here. Or Nathan's here, sorry. Nicolosi your last name. Okay, Nathan's here. All right, that's a division problem. By the way, sorry to say this again, Wednesday morning, 8:30, in the middle of this class, this building will have a fire drill. You may have seen the signs as you came in. That's going to happen. I was telling the rest of the class, they've directed us to take everybody out the back door. You know, that's not a good idea. Yes? I can't hear you. Oh, really? Did they? Example 5? Is that what you said? Example 1. Okay, example 1 we did earlier. Example 1 was back on page 203. We've already done that, haven't we? Yeah, we're at 205. Complex fractions. Is that right? I mean, I want to make sure I didn't have a brain blockage. Okay. But anyway, you shouldn't be thinking those things. Okay. But we will have a fire drill, evacuation of the whole works on Wednesday morning, 8:30. However, I've suggested, and I hope they follow through with it, that you go out the door you're supposed to go out, which for us down this half flight of stairs, take a left, go down one complete flight of stairs, and then head out of the building. Once we're out there, we're not going to do something different. We're going to go to the back parking lot because I think they want to talk to everybody together. If it were a real fire, we would head to that parking lot, as far away from the building as we can, not alongside the building, okay? But we'll go to the back because that's what they told us to. All right, so y'all said this was a division. You're absolutely right. This would be 4 over x divided by 2 over xy. What would you do with that? Flip it, yeah. Keep the first, 4 over x, just like it is. Never change it. Change that to a multiplication problem. Mark Jalen here and proceed. If I can find you. The light is so bright it's blinding. There you are. Okay. Change the division to a multiplication and multiply by the reciprocal, xy over 2. Now what? Okay, and what do you see? Okay, 2 will go into 2 once, 2 will go into 4 twice. Anything else? X will go into x once, and x will go into x once. Okay, and what do you have then? 2y over 1, or just 2y. Exactly. Pretty simple, right? That's a good, simple, straightforward, easy way to do the problem. Let me show you an alternative that I think, frankly, is even easier. Okay? But if you like this way best, it works, it's correct. In most of these problems, what I suggest that you do is look for least common denominator of all your denominators, both in the numerator and the denominator. But what are your two denominators here? X and xy. What's the least common denominator between those two? Okay, x is in both, but y is not up here, so you have to have it common. You'd have to have a y too, right? So xy. What do you do with it? Multiply by it. Multiply this by xy, and multiply this by xy. Okay? Now, you see what's going to happen now? This x and that x goes away, right? This xy and that xy goes away. And you also have, well, I'll write down the extra step. What you're left with is 4y over 2. And then you can divide out the 2. Another way to do it. Doesn't matter which way you go, but for me, most of the time, simplifying what they call complex fractions or complicated fractions, find that least common denominator, multiply everything in the numerator, everything in the denominator by the least common denominator, and that's guaranteed, because it's the least common denominator, to get rid of your denominators. And then you just have a rational expression. So, either way works. This, in a lot of other problems, will be the simplest way. In this one, both of them are pretty simple. Okay? You can pay your money and take your choice. You've already paid your money, so you just take your choice. Okay, any questions on that? Everybody see it? All right, let me clear those out of the way, and you can see, I think they show both methods. This type of problem is a simple division problem, so they change that from something over something to something divided by something. Perfectly correct, just like we did. And then invert and multiply, divide out common factors, and you wind up with 2y, just like we did. Okay? Ha! They showed you a lot of examples, didn't they? The easiest one, and then they went on. Okay, let's do some of the others. This is amazing. All right? Let's do example 6. Let's do this one. 1/2 plus 3/4 divided by 5/6 minus 3/8. Again, you have at least two ways to do this. Which way you want to do? It's up to you. You've already paid your money. You take your choice. So you like the first way, okay? That is doing 1/2 plus 3/4 in parentheses, okay? And this is pretty important, especially if you're doing it in this method, that you group the things together so you don't forget their order, okay? Divided by grouping these two, 5/6 minus 3/8. Now there's a reason for grouping that. It's not just for appearance sake. There's a reason for it. If you left these off, then according to the rules of operation, you would divide this before you added that. That's not what you do. You have to deal with the numerator first and the denominator before you do the division, so therefore it's most important that you group them. In fact, when you have this long division sign, that one, you just assume there's grouping symbols above and below. Even though you don't see them, assume they're there. Okay, what do you do next? Least common denominator, and you can do this separately because they are now divided by the division sign, right? So in the first group, what's your least common denominator? 4, okay? What do you have to do to the first, that 2, to make it a 4? Multiply by 2, and therefore you multiply the numerator by 2. So that gives you 2/4 plus 3/4. Don't have to do anything there. Again, group those together, and that's divided by, what's your least common denominator here? 24, okay? And what do you have to do to make that first denominator a 24? Multiply by 4. If you do that, you better multiply that numerator by 4. That would give you 20 24ths minus, and what do you have to do to that second denominator? Multiply by 3, so you have to multiply the numerator by 3, and that would give you 9 24ths. Okay? Now let's deal with those numerators. Okay? You got common denominator. 2/4 plus 3/4, how many does that come out being? 5/4, very good. I'll go and do a division again. Divided by 20 24ths minus 9 24ths. What does that yield us? 11 24ths. Okay, now what do you do? Yes, you keep the first, 5/4, and multiply it by its reciprocal, which is 24 11ths. Okay, now what do you do? Say again? Yes, 4 will go into 24 6 times. So your numerator is now 30, your denominator 11. Can't be simplified any further. Perfectly correct way to do the problem. You want to see it the other way? Oh, chicken.
We're good at it this one.
Huh?
So we're good at it this one.
You are. Let me just show you what the other is. Okay? It's not that bad. Look at all the denominators. What's the least common denominator of all of them? 24. Exactly. So let's multiply every fraction in numerator and denominator by that 24. Okay? What does that first fraction yield? 12. The next fraction? 4 going to 24. That would be 18, so that's plus 18. Divided by 6 will go into 24 4 times, so that would be a 20. And your denominator, that would be a minus 9. Perfect. And that gives you in the numerator 30, and in the denominator 11. Same answer. Frankly, to me that's a little easier. But if you like the other way better, knock yourself out. I mean, it's perfectly fine. Whichever way you see best. See that? Excellent. All right. That was example 6. Okay? The book on this one does show solution A, which was what y'all did to begin with. They did it in slightly different ways, but they still did it that way. And solution B is then the way that I did it. Again, either way works fine. All right. Ready for it? You need this any longer? Okay. Let's go to example 7. How about this one? 3 over x plus 2 over y divided by 5 over x, I can't write, minus 6 over y squared. Which way would you like to do it? Your choice. I don't care much. Okay? No, I don't care at all. Which way would you like to do it? You tell me. The second way? Okay? The second way was what I call least common denominator way. Okay? What's your least common denominator of all the denominators in both the numerator and the denominator? Yes, x, y squared. That contains everything. So what do we do with it? Multiply everything in numerator and denominator by xy squared. And why is that true? Because you're multiplying by x squared y squared over xy squared, which is 1. You can do that anytime you want to. Okay? Now, first entry there. What can you do to simplify that? Divide out the x's. And what does that leave you with? 3y squared plus, in the next term in the numerator, okay, you lose one of the y's, but not both of them, so that would be 2xy. Okay, denominator, divide out an x, and you get a 5y squared. And in the second part, you got minus 6x. What's that? Okay? Now, I look at that, and I ponder it a little bit. I can factor out a common factor in the numerator. Why? Okay? Second? Yeah, you can do that, but you can't factor anything out of the denominator. That is relatively prime. So then, what's the point in factoring out of the numerator if there's nothing to divide out the denominator? But it's not a bad idea to do, so let's do it just to show it. That would be y times, what would you have left? 3y plus 2x, okay, over, and you can't factor anything out of the denominator, 5y squared minus 6x. Nothing you can do. Is there? Is there anything else you can do to simplify that? No, don't even try. Okay, you can only divide out things that are multiplied. The only thing you got multiplied here is a y, which you don't have multiplied here, and the 3x plus 2, which you don't have multiplied here. Don't go any further. Now, you can still do this, that other method. If you want to see it, we can do it. You want to do the division method? Up to you. Go either way. Yay or nay? Go ahead. Okay. So let's do the division method if I can read my original problem. That would be 3 over x plus 2 over y divided by, be sure you group those, divided by 5 over x minus 6 over y squared. And what would you do first? Least common denominator of the first and then the second. You can do them separately here. But you see, you're doing least common denominator anyway, so it's up to you, okay? All right. Least common denominator in the first part? XY. What did you have to do to the first x to make it XY? Multiply by y, so you better multiply the numerator by y as well. So that gave you 3y over xy plus 2x over, yuck. Get to writing faster than I'm talking or something about that. Multiply the denominator by x over x, so that gives you 2x over xy. How about the second one? It's xy squared is your least common denominator. And what does that give you in the numerator? Yeah, you have to do a 5y squared, because you have to multiply both of these by y squared. And here, over here, you multiplied by x, and that gave you 6x. Okay, and that became, what's your, okay, say that one more time. No, you got a denominator, right? XY. What's your numerator? You add the numerators. You can only add like terms. Are these like terms? No, they're not. So you just say 3y plus 2x. Okay? Remember, divided by 5y squared minus 6x over xy squared. And now the last step is invert and multiply. Since I don't have much room over there, I'll do it up above. And this will be 3y plus 2x over xy times xy squared over 5y squared minus 6x. And what can you do now? Divide out an x, one of your y's, exactly, and this leaves you in factored form. See, this comes factored, y times 3x plus 3y plus 2x. Goodness gracious. Okay, all right. 3y plus 2x over 5y squared minus 6x. Same thing as we got before, and get out of there. Okay. So, both of them work. They come out the same. You're doing least common denominators in both of them. This one you have a little bit simpler least common denominators because you don't have to do them both by the smallest, but you wind up still fiddling around with both. That one gives automatically a factored form. This one, you have to look at it and factor if you want to, or you could have left it in that form anyway. All right. Both ways work. Any questions on it? Any? Can I go on and erase it? No. Okay, I'll keep it. Okay, there's two methods here. I'll separate them because I know you were out part of the time. There's the first method above the line, and the second method started here, went here, and here, then went up and over. Okay. Saw my little arrows there. I just don't have enough room. Limited screen. This is small screen mathematics, not big screen mathematics. Any questions so far? See what we're doing? One step at a time. Just take it easy, take it slow, go through it, make sure all your steps are right, and it should pan out at the end. Whichever way you choose to go. And in the text, it showed both solutions, solution A and solution B. And you don't have to know which is which, just either one. All right. Got it? Okay. Okay, let's move to, that was, I believe, example 7. Let's go to example 8. Okay, example 8. 1 over x plus 1 over y divided by 2. That looks like a much easier problem, doesn't it? Which way do you want to go on this? It really doesn't matter. Which way would you like to try? We can do them both if you want to. Which way would you do? Second? Okay, least common denominator? What's your least common denominator in both the numerator and the denominator? XY. Those are the only two denominators you have. So what will we do with them? Multiply the top by, each one in the top by XY, and multiply the denominator by XY. All right? What does that yield you in the first term? Okay, the x's go out, and that gives you a y, and then in the second one, the y's go out, and you got an x. And in the denominator, what do you have? 2xy. Guess what? You're done. That's it. Not much more you can do with that. No common factors. 2, there's no 2 up there. X's, there's no factor of x. There's a term of x with no factor. Y, there's a factor down here, but no factor up here. Yeah, that's all you can do. You want to see that the other way too? It really doesn't matter. It works just the same. Want to see it or not? Yay or nay? Huh? Do it, okay? What we would do there would be 1 over x plus 1 over y. Be sure you group those. Divided by 2. That's it. Okay? What you do to the first part? And what are they? xy, xy. What did you have to multiply the numerator by to make it the denominator? What did you have to multiply the first denominator? Okay, by y. So multiply the numerator by y. I got it all crossed up there. That would be y over xy, and this would be x over xy. Okay? Be sure you group them. Keep them grouped. Okay? So this would produce, when you combine those, add those together, what do you get? Say again? I couldn't hear. Okay, y plus x over xy. Can we go on and divide, change that and invert and multiply? What would that be? 1 over 2. And here, you just have numerator, y plus x, and denominator 2xy. Multiply them together. Both pretty easy. I don't think one of these is any easier than the other. It's just whichever you like best. You see how that works? Pretty straightforward. And they just showed the second method. So, didn't matter. First method worked just as well. Ready for the number 9? All right, let's go for number 9. Negative 3 divided by 2 over x minus 3 over y. Which way you want to go on this one? Second? First way? Okay. So how would you begin? Second? Multiply everything by xy? Okay. I called that the second way, but that's perfectly fine. Multiply the numerator by xy. Multiply this by xy. Multiply that by xy. Okay? What does that give you in the numerator? Negative 3xy. Pretty simple. In the denominator, first part, 2y minus 3x. Done. Nothing you can do to simplify that. Taken care of. Right? All right. Good deal. Any questions on that? Okay. How did we do it? Okay, the original was 2 over x minus 3 over y. So we looked at this. There's no denominators up here except 1. There's an x here and a y there, so the least common denominator is the product of x times y. So we multiply x times y by the numerator and x times y by both the numerator and the denominator. I mean, both terms of the denominator. Okay? So that yields you just a minus 3xy. Here, this x and that x divide out, leaving you just 2y. And here, this y and that y divide out, leaving you minus 3x. And that's all you got. Yes?
On the last step.
Yeah.
I, for some reason, want to divide that minus 3x on the bottom to the top. You know, divide them out. Why couldn't I do that? And why should I do that, though?
Okay, now where are you talking about?
The last step. You see when you got the minus 3xy? Your answer?
Yeah.
Your answer?
Minus 3x?
The solution. The solution.
Oh, there. Okay, right. Okay.
See how you got that minus 3xy?
Up here.
Yes. Then I see the minus 3x on the bottom.
Right.
I kind of want to cancel out that minus, well, divide that minus 3x by the top minus 3x. You know it's a y out there. I was wondering, get it out of my head.
Back when I was young, there was a song that said, you can't always get what you want. And just because you want to do that, you can't do it. And here's why. Because you can only divide out things that are multiplied. Down here, these are subtracted. These are multiplied. Yeah, minus 3 times x times y. Those are all multiplied. But up here, you've only got a subtraction. If you can factor something out, then that's multiplied. But as it's written, that's subtracted. You can only divide out things that are multiplied. That's the only way I can think of. That's how I see it, but there may be a better way. Good deal. Good question, by the way. I see so many people making an error like that. So I'm glad you caught yourself. Well, then, what are you doing with the sunroof? No, I'm just kidding. Okay. You mean the quiz?
Yeah.
Okay. I may have an extra one, but close your sunroof, okay? It's getting too cold for it, okay? No problem. Let me see if I have an extra one. Yeah, did anyone else need quiz 2? Okay. He's not going to give it. Oh, he is. Okay, okay. Anyone else need quiz 2? Okay. 2 more? Any more? Okay. Frank's lazy taking this. Okay. All right. Any others need quiz 2? Okay, we did have maybe one more person who withdrew, so I may have that extra. If not, I can make an extra copy later. All right. Any other questions? Let's move on to example 10, which is a little different looking kind of problem, but guess what? How do you eat that 5,000-pound elephant? One bite at a time. Okay, let's just see what's happening. Here we have 1 minus an n over 1 minus a 1 over n. You talk about complicated looking fractions. This is looking a little strange, isn't it? Okay? How would you approach that? Say again? Okay? Well, now, number 1, that looks like what we've just been doing, doesn't it? Okay, well, then just do that. 1 bite at a time. But don't forget your 1 minus. So leave your 1 minus here and do the second part. What do you do on that second part? How do you want to approach that one? And what is your least common denominator? N. That's all it is. What do you do with it? Multiply numerator by n and both terms in the denominator by n. Okay? Don't forget your 1 minus. What's your new numerator up here? N squared over n minus 1. That wasn't too bad, was it? Because here the ends divided out. Right? All right. Now guess what we have? No more a complex fraction problem. We have a subtraction problem. And we can handle that. We did that a couple sections ago. How do we do that? Whenever you're adding or subtracting rational expressions, what do you have to do? Find the LCD, least common denominator. In this case, what is that? N minus 1. You already got 1 here, so you're going to need to put 1 here. If you put an n minus 1 here, what did you better do also? N minus 1 in the numerator as well. Okay? Now,
How do you make n minus 2?
because here you have 1 over 1, and here you had n squared over n minus 1. What's your least common denominator? N minus 1. That's the only denominator you had except 1. So to make it common, you have to multiply over here, but if you multiply it here, you have to multiply it up there as well. Right? Okay? Now what? What's that first term give you? N minus 1. Whoa, don't forget. Minus n squared. Combine your numerators over your least common denominator, n minus 1. Right? Now, there's several things. Yes, I do want to rearrange. That's exactly what I was going to say. I don't like the way it looks, okay? I don't always get what I like either, but, you know, I can do something about that. I like for my n squared to start first, right? But I also don't like that negative coefficient, do I? So what we can do is factor out the minus sign in the numerator, get it out front, and then you have a positive n squared, a minus n, and a minus 1. Oh, plus 1. Plus 1. Very good. And that's all over n minus 1. Okay? Now the question I ask myself, can I factor that numerator? That's why I wrote it this way. And what I'm going to see is, no, I can't. I thought maybe I could, but it doesn't look like anyway. It'll only be n minus 1 times n plus 1, right? And guess, no, n minus 1 times n minus 1, that would give you a negative 2n in the middle, not a negative n. No way you can factor that. So basically, this answer right here is perfectly correct. If you wanted to rewrite it as minus n squared plus n minus 1 over n minus 1, that's perfectly fine. Or you could do what we did. All three of those are correct answers. You just can't simplify any further that I can see. Can y'all see any way to do it? And they left it in the other form. They put minus n squared plus n minus 1 over n minus 1. All three of those answers are perfectly fine. Now, if we were using WebAssign or some of those other packages like that, guess what answer they'd look for? You guess. You don't know. One of them, but only one. They tell you the other two were wrong. They're not wrong. They're perfectly correct. But you just have to keep guessing until you find the way. You think you made a mistake. No, you haven't. You got it right. You just don't have it in the form they were looking for. There is no one special form. Any one of those would be perfectly fine. Okay? So that's one reason I don't care for those computerized packages, because they restrict you to one answer, and there's not just one answer. Two of those, all three of those are equivalent. All right. Any questions? There are 7 true-false questions in Concept Quiz 4.4. Well worth your effort to do those. See if you can get them right. Turn one page over and you get the answers, so you don't have to question about it. There's also a number 8 there. Arrange in order the following steps for adding rational expressions. This is going back to adding rational expressions. So you arrange those, and then you see if that's what you get for number 8. Good deal. Any questions? Homework exercises, any of the odds, 1 through 39. There's a whole passel of those. Do some of the easier ones, some of the harder ones. You do several of those, okay? Then do any of the odds 41 through 63. Those are the ones we were doing today, the complex fractions. All right, any questions? And let me also say this, because I just want to make sure that you're still remembering it. Remember, we do have a paper in this class, a research paper. I've gotten quite a few from this class, like 2, okay, out of my biggest class, so don't forget them, okay? And guess what? You get a bonus point if you turn it in during the month of November, and guess what? November is dwindling away pretty quickly. I mean, it seems still early, but we're missing class on Friday because of Veterans Day. Then we miss a whole week. Y'all realize that because of Thanksgiving. So you don't have that many days to get it in. So please don't forget your paper. What's that? Research paper? Any topic you want that has to do with algebra. It can be a person, of theory, of application. It's wide open to you. You choose. All right. Any other questions? Did you have a question? I thought your hand was up before. Yeah.
No, I just needed this again.
Oh, okay.
Are we out that whole week?
Yeah, you are. We're not, but you are. Yeah. Sorry about that. I hate that happening. Yeah, that's miserable, isn't it? Terrible, terrible. Who would have thought of doing such a thing? All right. I think that is the last slide. Let's just see. Yeah. Okay. What's that? All right. Now we move on to 4.5. Yeah, we've got time. Plenty of time. Lots of time. Okay. Wishful thinking. Okay. Going to the next section, of course. I wouldn't want to cheat you out of a single penny of your tuition dollar, right? Good deal. Okay. So let's do the slideshow. I don't want you writing the dean saying, he cheated me out of my tuition dollar. Yeah. All right, we're continuing rational expressions. We have multiplied rational expressions. We have, we did some division of them. We added, subtracted. We did complex fractions. Now we're going to go back to dividing polynomials. Now we did a few rational expressions. Now we're going to divide polynomials. Okay? We'll divide polynomial, and then we'll come up with a new technique. And have y'all had synthetic division before? Okay. Well, it may be a new technique for you. You may have seen it before, but here's what we're going to do. Let's start with the simple ones, our monomials. And I hope you remember this. If you have the same base, but different exponents, and you're dividing, how do you do that? That could be 2 cubed over 2. What would that be? Yeah. Okay, you could either multiply them out. 2 cubed is 8, divided by 2 is 4. Or you could say 2 cubed divided by 2 to the first power, keep the base 2, subtract the exponent, 2 minus 1. 3 minus 1 is 2. That would be 2 squared, which is 4. And that's exactly what you do with common bases. If you have the same base, different exponents, you're dividing, keep the base, subtract the exponents. Numerator minus denominator. Let's go back and think. When you're multiplying, same base, different exponents, keep the base, add the exponents, of course. Okay? Now, so what would this be? Okay, first divide the numbers. That'd be 4 x squared. You got it. Y'all knew how to do this. Okay? What would this one be? Whoops, you have to see it. There it is. Not just 9. Negative 9. X to the third. Y to the third. Excellent. Y'all know how to do this. So that's what you do if you have monomials, numerator and denominator. Now, how about this? A over B plus C over B. What's that? A plus B over A plus C over B. Exactly. Same denominators, add numerators, keep the denominator. How about this one? A minus C over B, because you had common denominators. These are the basis for adding and subtracting rational expressions. We've done this. Been there, done that. Did y'all get a t-shirt? I don't know. But anyway, taken care of. Why are we reviewing it? Well, just for good purposes. Okay? Now, what if we went the other way? What if you started with A plus B over C? How could you write that? A over C plus B over C. You can undo it. You can go the other direction. Same thing here. Absolutely. Okay? And that's what we do quite often when we're dividing by monomials. Along with our knowledge of dividing by monomials like we just did earlier, that provides a basis for dividing polynomials by monomials. Okay? Guess what we're going to do first on that? Okay, yeah, let's separate them. Let's do the first part of the numerator, 18x cubed over 6x, plus 24x squared over 6x. Now you do each of your monomials. And what would the first one be? 3x squared plus 4x. You got it. Excellent. Okay? How about this one? What would you do first? Separate them, and that would be, well, I'll do it one at a time. 35x squared y cubed. I know you could do it. 5 over 5x y squared. Minus 55 x cubed y fourth over 5x y squared. Now let's do the first one. You were doing it. 7x y, perfect. Minus 11 x squared y squared. You got it. Okay? Now, when you get an answer like this or like this, you could factor further, but what good is it doing? It's just an extra step. Both answers are right. That answer is right. If you had a denominator, you might want to go on and factor, but without a denominator, there's no reason to. Both of those, you can factor out x, y down here. But again, why? There's not really a good reason to do so. All right. Now, to divide a polynomial by a monomial, divide each term of the polynomial by the monomial. Like you said, separate them. As with many skills, once you feel comfortable, and you are already doing it, you may want to perform some of the steps mentally. You were already doing that. You were dividing one and the other, just taking it as you go. So let's try this one. As you were trying before, what would that be? 5x squared y fourth, very good. Plus 9 x cubed y 6, very good. Excellent. How about this one? Okay, someone else got it. Come on, somebody. Anybody? Okay. Say again. Negative 4ab, got it. Plus, because minus over minus is plus, 5 what? A squared, b cubed, you got it. So you see, you can still write them out if you want to, or if you can see how to do them rapidly, do them rapidly. Just don't go too fast. I mean, don't get ahead of yourself, okay? Be in your comfort zone, okay? Stretch yourself, but stay with it. Now, what about something like that, though? It's got a binomial in the denominator. You can't do the same thing. Okay, yes, you first see if you can factor that numerator, and then see if maybe it'll go into it. And because x will go into 3x squared, or 4 will go into 4, there is a chance. It may or may not work, but give it a shot, okay? If you were trying to factor that, what would that be? Second? Okay. I'm sorry, I can't keep it covered, so. Right. If I were doing this, I would, whoa, I've got to get my pen back. Okay. We would hope, well, I'll factor it up here, okay? We would hope that x plus 4 would be a factor. There's no guarantee it would. But if it were, what would that first one have to be? 3x, and the next one would be a minus 1, right? Let's see if that works. 3x times x is 3x squared. Okay, that part works. 3x times 4. Positive 12. 12x minus x would be 11x. Look at that, and minus 4. Yes, it does. It's not guaranteed, but this one it did, and because you have x plus 4 in numerator and denominator, divide it away, and you just are left with a 3x minus 1. Okay? It won't always work that way, but give it a shot and see if it will. We can obtain the same result by using the dividing process, similar to long division in arithmetic. Let's back up and remind. Do y'all remember how to do long division in arithmetic? No, you had calculators your whole life, and you don't remember how to do it, do you? Let's see. Let me back up and see if you can remember how to do this. Let's do 14 divided into 3, 1, 1, 4. Whoa, that went out of, kind of got carried away there, didn't it? Okay, let's get that back down. Okay, see if we can write that just a little better. I don't know if this will go in, but let's give it a shot. How would you do that long division? Put the calculators aside. How would you do those long division? Okay, 14 in the 31, how many times? Twice. Then you do what? Multiply. Yeah, you divide first and you multiply, and that gives you 28. And what do you do next? Subtract, okay? Divide, multiply, subtract. And what does that give you? Second, 3, and then what do you do? Bring down a 1, okay? And then what? Divide again. 14 into 31. Twice again. 28, you multiply again. Then you subtract. 3. Bring down the 4. I'm going to change. I wish that came out evenly. It doesn't. Let's see if I can make it. No, I can't. If we change the numbers, it could have been. But you see the idea. 14 into 34. It goes twice again, and that would be 28. And then you had a remainder of 6. And you could write that as plus 6 over 14, which you could simplify to be 3 over 7. Okay? You can do that. We're not, this is just a reminder. Okay? But this is how you divide numbers. Let's see if we can do the same type thing with dividing polynomials. Okay? Have y'all done this before? X plus 4 divided into 3x squared plus 11x minus 4. Now this is the same problem we just did, but we're going to do it by dividing this time. I agree, factoring was easier. We're going to show that you can divide. Now, what was different about dividing numbers than multiplying, adding, or subtracting numbers? When you add, subtract, or multiply, you usually start on the right and work your way left, don't you? With dividing, you start on the left and work your way right. Okay? Do the same thing here. Guess what we would try first? X will go into 3x squared how many times? Say again? 3x times. Just like that was a monomial, remember? So there was our dividing part. What's the next step we did? Multiply. So let's multiply. 3x times x is 3x squared. But you also have this 4. So 3x times 4 is plus 12x. Okay. What do we do next? we subtracted. Now, since with polynomials, you'll quite often have signed numbers. When you subtract signed numbers, I like to change signs and add, okay? Just because I tend to make fewer mistakes that way. So I like to change the sign and add. So that's what I'm going to do. I'm going to change the sign of this and make that a minus and make this one a plus, okay? No, I made that one a minus 2. I made them both a minus. I don't know what I'm talking about. They were both pluses, so I made a minus. Now I add. When I add 3x squared minus 3x squared, that adds a 0. That's why I did it. When I add the other, what do you get? Yeah? What do you get? Negative x. And then you do what? Bring down the negative 4. And then what? What do we do next? Divide again. X and the negative x will go how many times? Negative 1 time, right? And then we did what? Multiply, right? Okay, minus 1 times x is negative x, and minus 1 times 4 is minus 4, and guess what? When you change signs and add, that goes to 0. That means this thing multiplies by that thing, gives you that thing. That's what division does. It undoes multiplication. How do you check? You do that. So you see, just like before, we got a 3x minus 1. Now we also got a 3x minus 1. Remember we did it before? 3x minus 1? We do it here. Okay, here's how they start. Write this x plus 4 outside the house, thing in the denominator. Write the numerator, the bigger one, inside the house. And then you do your division. First you divide. X and the 3x squared is 3x. Then you multiply. 3x times x is 3x squared. 3x times plus 4 is plus 12x. Now, they, I think, will say subtract. Okay? But I like, and that's what they're saying too, add the opposite. So change this from a plus to a minus, that's minus, minus, and then add. Those go out, that becomes a minus x. And then, just like before, bring down the minus 4. Then, divide again. X will go into minus x, minus 1 times. Minus 1 times x is minus x, minus 1 times 4, minus 4. When you change signs and add here, you get 0. So that meant this went into that exact number of times. That was a factor. That's how we do long division of polynomials. Make sense? It's a lot like long division of numbers. You need to see any of the steps again?
That minus 1.
Okay.
What that minus 1?
Okay. You do x into minus x. Okay. Let's go back to this. Remember, once you subtracted, you brought down, and then you did this into this again, right? That's a division again. Well, you do the same thing here. You do x into minus x. Well, that goes at minus 1 time. Why? Because minus 1 times x is minus x. And minus 1 times 4 is minus 4. You're trying to get the same thing here that you had there. That's what we did here, right? X will go to 3x squared, 3x times 4. When you multiply, you get the same thing. You can subtract them out. Same thing down here. X will go to minus x, minus 1 times. Then you multiply. And then when you subtract them out or change signs and add, in this case, it all goes to 0. That won't always be the case, but here it will. Okay? That's how you divide by long division of polynomials. All right, here we have another one. Ready to start it? How much time do we have? 3 minutes? We can do it, can't we? Sure we can. What goes inside the house? What goes outside the house? X plus 2 goes outside the house. What goes inside? 5x squared plus 6x minus 8. A little time out here, okay? When you're dividing polynomials, be sure that your polynomials are in descending order of the powers. Absolutely. If you don't have it that way, you're going to get all screwed up. Also, another thing to watch for, make sure you're not missing any terms. Look at your exponents. 2, 1, 0, 1, 0. Be sure they're in descending order of powers. And that you're not missing any. If you're missing one, if this was x cubed and an x, you'd have to put a 0x squared in there. You've got to account for every term. Okay? So, what do we do first here? X will go into 5x squared how many times? 5x times. Got it. Next, multiply 5x times x, 5x squared. And 5x times 2 is plus 10x. Now what? Change signs and add. Okay? All right. And what does that give you? That goes to 0. This is negative 4x. And do what? Bring down your negative 8. Then what? Negative 4 times. Then what? Multiply. What do you get? Negative 4x. Negative 8. Look at that. We got another one that factored exactly. No remainder. Okay? Very good. Let's see how they did it. We'll do it quickly. Is that okay? They divided. They 5 into 5x squared. I mean, x into 5x squared is 5x. 5x times x is 5x squared. 5x times 2 is plus 10x. Subtract or change signs and add. Minus 4x. I like to change signs and add. Minus 4x minus 8. X will go to minus 4x minus 4 times. Minus 4x minus 8. 0 remainder. There you go. Okay? Make sense? All right. Now in this section, I'm sorry we ran out of time. Okay? We've done example 1, right? We are getting ready to talk about recall right there. This is on, we got down to page 212, okay? Let me see, I think we got a few homework exercises we can do in this section. Making good progress here. Do some of the odds 1 through 9. Oh, you can do all those odds 1 through 9. Then do some of the odds 11 through, let's see, 11 through 15. And we'll do the rest of those later. That's on page 216. Okay? Second? Yeah, we had some from the previous section, right? Okay, good deal. I see some quizzes ready to come in. Very good. Excellent. Those can come in any time. Sooner the better, folks. And by the way, if any of you haven't finished the first quiz, please get those in. If you haven't done the first test, please get those in. Okay. It's up to you. If I see your work, I might be able to get more partial credit. All right. Yeah, sneak on by there. Okay. All right.
I think that one was much easier than the first.
I thought so too. Yes, ma'am.
Okay, is it possible you could tell me if this is right or not?
What's that?
Is it possible you could tell me if this is right or not?
To do what?
Can you tell me if this is right or
Oh,
not?
if it's right or not. Okay, I'm
This
sorry.
dealt one.
Okay.
Because I think I forgot how to do it, but did I do it right?
Okay. Now, here's the problem. What's your least common denominator?
32. And
How
I
did you get
multiplied
that?
that by
Wait.
6.
How did you get that?
But then 6 and 7 have 32 coming.
Try it again. What's 6 times 7?
32, ain't it?
42.
Oh, okay.
Except for that, you're doing okay.
I can work on test 1 some more and go try to get finished.
Yeah, absolutely. Soon as you want to do it now? Okay, fantastic.
I got a few minutes.
All right. Let me get it to you. Test
I
1.
get as much of it done as I can. Hopefully, I get
Absolutely.
it finished and get it in.
Yeah. Okay, test 1. I know you're in here somewhere. You're right near the top, but I can't get. Oh, there we go. Close. Just real close. There you are. Okay. You want to go back next door? You can.
You go in there?
Yeah, that'll be, if there's no class in there, absolutely. Yes, sir.
Can I have a copy of that second quiz we have?
Second quiz, okay. I know I have them in here somewhere. I think I do anyway.
That's no stack.
I know you don't want the key. Okay. There you go. Good
Thank
deal. Uh-huh.
Well, all I had to do was change that to 42, but is that right? Is that the type of answer I'm supposed to get?
Okay. All right, let's just see what you did now. That'd be 7 times that. That looks good. What's 6 times that? That looks good. What's 6 times 5?
Okay,
How am I supposed to say if it looks right or not? Huh? I better turn this off. I'm recording.